Since the heart is autorhythmic, basically meaning it can control itself, it can create its own heartbeat, we need to look into this intrinsic cardiac conduction system. Now, there's a whole paragraph I have up here, and I know it's kind of a lot for a slide, but the idea here is you have these non-contractile cells. The non-contractile cells are the ones that actually distribute the impulses. They're the ones that are kind of in between the different cardiac muscle cells. There's certain areas and certain pathways throughout the heart that they basically are found in. They're going to coordinate the depolarization and basically stimulate the depolarization of the cells around them. By doing this, they're allowing the heart to contract in order. Atria first, ventricles second. This allows the blood to be pushed from the atria down to the ventricles, then ventricles out of the heart. So there are 5 main structures you look at for this entire autorhythmic system. First one is the SA node or sinoatrial node. Now this SA node or sinoatrial node is kind of known as the pacemaker. The reason being, as long as your heart is healthy, this is what sets the pace. Normally, this fires off and creates about a 75 beats per minute heart rate. You say, well, my heart rate isn't 75 beats a minute. That's fine, no worries. Could be higher, could be lower. This is just what would be set if there was no outside influence. Now, think about it this way. Your brain, also you get you get all nervous. Your heart rate can go up. Or maybe you're exercising and your muscles need more blood. Heart rate goes up. Maybe really calm down and relaxed. Heart rate goes down. The idea is the sympathetic system, the parasympathetic system, the brain is overall has a cardiovascular system in it. Your muscles, your respiratory, a lot of these things influence the heart rates. What is the health of your heart? How much cardio exercise do you do? Do you do a lot of long endurance running? All these things can impact what that heart rate is. But without any of that influencing it, the SA node fires off about 75 times a minute, which means your heart rate would be set at 75. So that is the SA node or the sinoatrial node. It's what initiates the beat. Now after that, the next main structure is the atrioventricular node or the AV node. We're still up in the atria, specifically the right atrium, but this actual AV node has smaller diameter fibers, not quite as big. And the main purpose here is a 0.1 second delay. You're saying, well, 0.1 second, that's not very long. No, it's not. But when your entire heartbeat is just under a second, you're talking about 10% of that time. So the question is, why would you need to delay it? Why need to slow things down? You need to give time for the blood to get from the atria down to the ventricles. So now the atria to ventricles, that's a passive fill the whole time until the atria start to contract. When they contract, you have to have enough time to get the blood pushed out down to the ventricles. So a 0.1 second delay, just a pause until it moves on. Now, in the case of the SA node being damaged or not functioning properly, the AV node can depolarize about 50 times a minute. This would create a heartbeat of about 50 beats a minute. Now, for majority of people, that's slower than normal. I say majority because some very highly trained endurance athletes can have heart rates in the 40s even. But for most people, 50 beats a minute isn't quite going to do what needs to be done. So this would still keep you alive. You'd be alive with this, but you might feel sluggish. You might not have the same energy. It'd be harder to catch your breath. You'd be telling there's something not right here if all of a sudden your heartbeat is 10, 20 beats lower than normal. So it's kind of a backup method, let's call it that. The third thing here then is the atrioventricular bundle, the AV bundle, also known as the bundle of His. So we have multiple names, again, pick one, but the AV bundle or the atrioventricular bundle. Now this atrioventricular bundle is the only electrical conduction between the atria and the ventricles. Why is that significant? That means it's the only way to get this signal, which is your heartbeat, from the atria down to the ventricles. Without this, the ventricles cannot receive that signal and create a heartbeat. So it's the only way of getting it from the atria to ventricles. We then have the right and left bundle branches. So after the previous step, it branches out into two. Well, we're going to have two pathways going down the interventricular septum. Now, as this heads down the interventricular septum, it gets to our last point, which are the Purkinje fibers. Now, these Purkinje fibers aren't just one spot, but they're many different fibers that are all going out into the ventricular walls. These Purkinje fibers are what will trigger the depolarization of the ventricle. So basically, this is what causes your ventricles to contract. Now, as a last-ditch effort, fail-safe method, the Purkinje fibers can depolarize about 30 times a minute. That's if there's no AV node input or SA node input. So it's kind of like a backup to the backup. And at 30 beats a minute, you're going to be really feeling that. You're not going to be feeling well. You better find yourself a hospital quick. But this would still keep you alive, at least for a little while. So you have these backup to backup systems here. So 5 main structures for this conduction system in the heart, this intrinsic conduction system. And again, this all can be modified based on the external factors as well. So let's take a look at what we're seeing and where they are. So a couple things are already listed, different structures. But look at the SA node. The SA node is just this thing up top. It's at the most superior aspect of the right atrium. So that is what, again, was the pacemaker. It sets the heart rate. It starts the depolarization process. From there, that depolarization wave, as you guys see, it's going to travel over here and travel down. The idea is you're trying to get out to the left atria and all the way through the right atria. To do this, you have this anterior, middle, and posterior internodal. That's these yellow lines coming down. It's helping to carry the signal down. You also have this Bachmann's bundle carrying it over to the left atria. So that helps with the depolarization of the right and left atria in synchrony. They must contract together. From there, remember the next main step was the AV node or atrioventricular node. That's this structure right down here. It's a little bit lower down in the right atrium. It's going to pause the signal just for a moment. From there, the signal will head down towards the ventricles. That's the atrioventricular bundle. That's this line coming down. The atrioventricular bundle allows that depolarization wave to travel down into the ventricles, where it goes down into the right and left bundle branches. Those right and left bundle branches are going to head down the interventricular septum, and they'll start to kind of branch around until they meet the different points of the Purkinje fibers. Now, the Purkinje fibers are these things out in the ventricular walls. So it's the parts that branch out into the ventricular walls. It's what will actually cause the depolarization of those cardiac muscle cells in the ventricular walls, which means those Purkinje fibers cause the ventricles to contract. 5 main steps of the conduction system here, starting with the SA node, to the AV node, to the AV bundle, to the right and left bundle branches, to the Purkinje fibers. So if we're looking at it as where is the depolarization occurring at different points, the purple here is showing depolarization. So you start off with the initial signal being sent off. We're up top here. You can see that we've depolarized, it's starting to spread. that is going to be just a little bit of purple around that area. It needs to spread out for the entire atria, both right and left. Again, they have to be together. From there, you can see the depolarization travels right down that structure, from the AV node to the AV bundle, going down to the bundle branches. From there, once the Purkinje fibers are initiated, you start the contraction of the ventricles. Now you notice it starts to contract at the apex, hence why it's shaded going up, and then full contraction causes the entire ventricle to contract. After that, it's repolarization and back to step one, starting over again. Few different imbalances, some problems that can occur. Now, this intrinsic conduction system, you hope there aren't problems, but sometimes things like arrhythmias, which is an irregular heartbeat or irregular heart rhythm. Something isn't quite firing properly, or some outside structure force is causing an improper balance. Maybe your brain isn't quite controlling it the right way. So arrhythmias, unusual or irregular rhythm. You have uncoordinated atrial and ventricular contractions. Well, why would it be an issue if they're uncoordinated? As long as the atria contract and the ventricles contract, you're good. Yeah, not so much. Because if the ventricles contract first and then the atria, it's not efficient. Because all that blood from the atria isn't getting into the ventricles first. Or if the right side contracts before the left side, for example. Also, now you end up with a backup of blood going into one of the systems. So it's important to have the coordination, both atria together, and then both ventricles together after that. Fibrillation, rapid irregular contractions. So you might end up having, if your heart beats like say 75 beats a minute, this could be 80, 90, 120, 140 beats, but they're not in proper order. It's very fast, couple big, couple small, on and off, on. It's completely a random mess of contractions. So fibrillations, there's atrial fibrillations, and then there's ventricular fibrillations. Atrial fibrillations aren't great, but as long as the ventricle is still contracting normally, a person's still okay, but they need to see medical treatment. Ventricular fibrillations, that means you're not even getting blood efficiently out of the heart. You better be seeing medical intervention very quickly in this case, for the most part. So a little about fibrillations there. Arrhythmias, uncoordinated. Unfortunately, there are problems that occur with the heart. So we're looking at some different problems as well as normal functioning through the intrinsic conduction system.